Well, there's a few other features I want to talk about. Oh, in regards to the ocean, I'd call it ocean stuff. The first one's a longshore current. Yeah, I'm not going to read all this, and then we'll skip to the slide. You can read this on your own, take notes on that. But simply put, a longshore current, when waves hit the shoreline, very seldom do they hit at a 90-degree angle. So as they hit at an angle, again, the law of reflection, it will bounce back at the angle. And what happens, you get wave after wave hitting at that angle. What you start setting up is this current that goes along the shore. And if you've ever been out Lake Michigan, an inner tube or some type of inflatable object, if you're sitting here and you're here, you'll notice after a while you're actually drifting along the beach. Well, that's because of this longshore current. This next term, upwelling, we've discussed quite a bit. And again, you can read this on your own. That upwelling, we looked at the west coast of South America and lately the west coast of the United States, California in particular. We have this cold water current flowing down, going towards the polar regions, and we got this offshore water. So what's happening is it really, lack of a better term, brings up this cold water. And it contains nutrients. That's why the fishing industries are so good. And also, it's going to contain sediment. So this is going to increase the salinity of this water. Remember, all these sediments come off the shoreline or off the continents, and those are the salts. And so we looked at this quite a bit with California. Wave refraction. Again, refraction is the bending of a wave due to a change in speed. And we're going to look at this picture here. Probably maybe they're refracting here, really on any headlands. So as these waves are approaching the shoreline, they meet or feel bottom sooner here than they do there, so they turn in this direction. They refract. And next time you're at Lake Michigan or so, if you get on a little bit of a point, you can see waves refract or bend because they touch bottom sooner here than they do in this part, so they are bent. One thing we talked about earlier in the year, if you had one foot running in sand and one on concrete, you can continually feel like you're turning towards the sand or you're refracting. And that's the same thing that's happening here. A beach, we discussed in class, but technically it is a part of the shore that's washed by the tide or the waves. That's the technical term for a beach. And again, it could be sand or pebbles, and large rivers, lakes, etc. can have beaches. A breakwater is a structure used to protect coast from eroding. Also, it gives it a chance. You put boats in here, protect a harbor, and you can see on this picture here, very little wave action going here, and quite a bit there. Next time you get out to Grand Haven or Muskegon or Holland, they have these breakwaters. Again, the water breaks on these structures. Rip tide, which is the misnomer, is really a rip current. It is a rip current. People always want to call it the rip tide, but it is a rip current. And I'll let you read this, and we'll look at the picture. So with our rip current, and you can see the rip current right in here, goes out in this direction. Well, you can see what ends up happening here as these waves strike the beach and go back into the water. You can see this little indentation here funnels this water into a narrow opening, and so it creates this current going out. And as we discussed in class, people drown every year. Lake Michigan has quite a few rip currents. The best way to get out of one is just to float out, and you see it ends, or to swim perpendicular direction or parallel to the shoreline, perpendicular to the rip current or parallel to the shoreline. Do not try to swim against it. And again, you can see this feature is funneling this water all back into this current.